7.5. Is it proportional? Let's look at some examples. Review. Y plus 2 equals 6. The variable is y. A plus b equals 10. The variables are a and b. If we have a ratio table like this, the variables will be n, probably how much you buy, and how much money you spend. Dependent, independent. We need to understand what those words mean. In this, we can say that the baby depends on his mother. So the baby is the mother's dependent. And if the mother is not taken care of by anyone else, the mother is independent. So here's a 1040 tax form. The tax form asks you if you have any dependents. It's really asking you if you have any children, because we know your children, well, children that depend on you anyway. Okay. If your children are 30 years old and working and supporting themselves, they are no longer your dependent. If your child is 3 years old and need you, then they are your dependent. In science, we have dependent and independent variables. For example, we might change the number of light bulbs, and we find that, hey, the light bulb is more bright. When we change the voltage, the current also changes. We are changing the voltage. That's the one we choose. That's the independent variable. That causes current to change. Current is the dependent variable. In math, if Khan buys 2 packs of chestnuts, it costs $4. Well, 1 pack would cost 2, of course, because if 2 packs cost 4, then each one is 2. So how many packs that Khan buys, he chooses. That's the independent variable, because he chooses that one. How much it costs depends on how much we buy. That's the dependent variable. We usually put the independent variable on the left, depend on the right. That's what we usually do. That's convention. So if the independent, in these problems, when the dependent variable is 0, what is the independent variable? In class, we looked at the do-nows, and we noticed that when we buy nothing, of course it costs nothing. If we don't buy anything, it costs nothing. So it's always 0. As it turns out, whenever this is true, we can say that the two variables are directly proportional. Well, one of the conditions is when the independent variable is 0, the dependent variable is also 0. Okay. The other condition, as we've seen in the past, is you're always going to be multiplying or dividing by the same number. So for example, this one, is it proportional? Yes. Because 0, 0. So the graph's going to look like this. We start at 0, 0, which is here. This one, is it proportional? No. Because when x is 0, y is not 0. In fact, there's a y-intercept that's not 0. We start here, like that. Okay. So things are directly proportional. Well, this one, because y is just 2 times x. This one has a y-intercept is equals y 5. When x is 0, y is not 0. Not directly proportional. Now, if Clayton is saving money to buy a new phone, he has $200 right now. That means that when x is 0, y is 200. So it is not directly proportional. They are not directly proportional. I'm using they are because there are 2 things here. Time and money. Miss Kogan takes the plane from Boston to Miami. The plane flies 1,000 miles in 2 hours. How far does she travel in 3 hours? So when the time is 0, the distance is 0. Right? So we can say that, yes, those 2 are directly proportional. Okay? They are directly proportional. So how far does she travel? Well, we know that 2 hours is 1,000 miles. So that means each mile, each hour has to be 500. Okay. So if we go one more hour, it'll be 500 more miles. So it's going to be 1500. We can also use time and distance. Use the table. 2 hours, 1000 miles. So 1 hour, 500 miles. So 3 hours, 1500 miles. So that's the answer, 1500 miles. Okay, that's it.